Hi everyone, I'm Mayor Eric Garcetti, and I'm so thrilled to welcome you to the City of LA's first ever Smart Cities Conference. LA is a city of dreamers and doers, a place where people come from around the world to be bold, to think big, and to glimpse just a little bit of the future. It's the spirit of our city. It's the spirit that drives us to meet current public health and economic crises with creativity and strength and resolve. It's what brings us together today. By investing in smart and innovative technologies, we've opened the door to a city that works for everyone. We've achieved a more digitally accessible city through expanded 5G, a greener city through EV charging stations and air quality meters, and a safer city by installing smart nodes to adjust lighting at large events and in public spaces. These are just 3 examples of how we can make our city better. Whether it's a more beautiful city with our Streetlight design competition and so many other cross-sector collaborations, or today's conference, which is about doing even more, using the power of partnerships and innovation to make Los Angeles better, healthier, and more equitable for everyone. I'm so grateful for the efforts of our city leaders and our departments, our Bureau of Street Lighting, ITA, our Board of Public Works, and all the staff who have brought us to this very exciting day. And I'm inspired by the diverse group of innovators, designers, and thinkers who have joined together for this endeavor. Whether you're here representing a tech startup or a telecom company, a nonprofit, or another city, you are helping us all write a new and dynamic chapter for communities here in LA, across this country, and around the world. Smart cities begin with you, with the conversations that will happen today, and then the vision that we build together. And there's no time to lose, so let's get to work.
Welcome to the City of Los Angeles. Today we are excited to bring you our first ever Smart City Streetlight Conference. My name is Garcia and I serve as the Vice President for the Board of Public Works. Here at the board, we are 5 commissioners appointed by the mayor, where we have direct oversight of all city services. So whether it be filling in a pothole, picking up the trash, or turning on the lights for our 4 million residents is what we do here at the board. But today, we are especially proud of the Bureau of Street Lighting for bringing the city into the new age technology. I want to take this time to thank Norma Isahakian, our Bureau of Street Lighting Director, for leading the way. So from wherever you're joining us today, whether it be your living room, your office, or even the park, we thank you and we hope you enjoy this year's Smart City Streetlight Conference.
Welcome to Los Angeles' first Smart City Streetlight Conference. My name is Norma Isahakian, and I am the Executive Director for the Bureau of Street Lighting here in LA. This conference is focusing on the City of Los Angeles' streetlight system that is rich with history dating back to gas lamps installed in the 1860s. Since then, we have seen such a transformation in the streetlight world, in design, and most recently in technology. The streetlight is no longer just a pole with a light. In 2014, the artist Chris Burton, in describing his installation Urban Light, which consists of 202 cast iron streetlights arranged along Wilshire Boulevard, marking the entrance to the Los Angeles County Museum of Art, said something that has stuck with me. The design of streetlights, he noted, reveals something important about what constitutes a civilized and sophisticated city, safe after dark and beautiful to behold. This statement embodies the Bureau of Street Lighting's mission: repair streetlights that are not working, construct new streetlights to brighten a community's night, use our streetlights to define a community's personality, and ensure that the City of Los Angeles' streetlight live up to the historic beauty of their iconic designs. This conference will explore the next transformation into the role of the streetlight in a smart city. I am so excited to share with you some of our exciting programs that have been in place for a while, our successes and lessons learned, but also I want you to listen to our Smart City presentation of our current projects, future ambitions, and imagine what can be. This conference is broken up into several segments, each with a theme. We have a Smart City section, EV charging stations on streetlights, co-location with our communication partners, and segments delivering public safety and maintenance. Also, don't forget to visit some of our gems, including our museum virtual tour, the presentation of the winning design from our streetlight competition, and short videos from other cities on their exciting programs. I want to thank those cities that participated and hope you will find their segments informative. If you have any questions, please email them to lastreetlightsc@lacity.org. We will answer those questions that are sent to us today between 10 and 1 o'clock. All answers will be posted and emailed to all those that are registered. Well, it's time to get started, and thank you for joining us today.
Hi, I'm Megan Hackney, Assistant Director and Executive Officer at the Bureau of Street Lighting. I oversee our community services work, our admin, and our field operations, who maintain over 223,000 streetlights. In this presentation, I'm going to bring you into the world of streetlight maintenance and share with you a few of our successes and our challenges. Today, I'm going to give you a brief look at our field operations, maintenance, and repair program. The Bureau of Street Lighting has various lighting programs that have grown and evolved throughout the years, but the maintenance and operation of our streetlights has been our backbone for the last 95 years. The City of LA spans 469 square miles, and about 2/3 of that area is lit with streetlights. We have approximately 223,000 streetlights, which we own, construct, and maintain. The Bureau is able to manage information on this vast system of streetlights through our internal asset management system, also called the AMS. The AMS has information on all of our streetlights, including pole and lamp type, installation plans and dates, all incidents and maintenance work records, including staff and fleet usage, as well as any attachments that the pole may have. The city's 311 system automatically transfers reported streetlight issues into the AMS, which helps with crew deployment and the tracking of incidents. So who is behind the construction, operation, and repair of these 223,000 streetlights and all that goes with them? That would be our Field Operations Division, affectionately called FOD. Most of our crews at FOD work out of our main field office, which is located in East Hollywood. We do have a small shop in the Valley that we share with other city departments, which enables us to cut out some travel time and centralize work that is specific to the Valley area. Our main FOD yard is a 5-acre property that we are quickly outgrowing. We have 217 field staff and crews and a fleet of 130 vehicles. Although the majority of our field crews are electricians and electrical helpers, we also have painters to keep our poles beautiful and in good condition, welders to weld pole base doors to ward off wire theft and do pole repairs or to complete fabrications necessary to make streetlight repairs. We have maintenance and construction helpers to help with construction type work, cement workers who are responsible for constructing foundations, and warehouse staff to run the 2 warehouses that we have on site. Our maintenance program is divided into 5 geographically based districts to cover the various areas of the city. It's common for people to think that streetlight repairs are just changing light bulbs. In reality, repairs can be very complex and complicated depending on the nature of the problem. This slide shows our common repair requests to give a general idea of the assignments our maintenance crews will usually see. This slide gives a snapshot of what our maintenance crews did last fiscal year, which just ended in June. They repaired over 45,000 streetlights and ensured that at any given time during the year, more than 99% of our 223,000 streetlights were operational. As you can see in the graph, the majority of repairs were single light out repairs. These repairs are generally straightforward and fairly quick. Coming up behind the single light out repairs is multiple lights out and vandalism. Unfortunately, these repairs are often more complex, time-consuming in nature, and may require multiple weeks to close out. One of the biggest challenges that we're seeing in maintaining a fully operational street lighting system is copper wire and power theft. While this issue has been with the Bureau for many years, the last 2 years, theft has really ramped up and kind of challenged our resources. Not only is wire theft dangerous and it creates liability issues for the city, it often knocks out blocks of streetlights at a time and requires extensive and timely repairs. So really, it's pulling our resources from other maintenance needs and programs that we have. Power theft is a more recent dilemma, which creates its own challenges. Power theft is when our pole boxes or base doors of streetlights are damaged and removed and the wires get tapped into. Usually we see this to attach extension cords or some sort of charger that run to RVs or encampments. The result of the lengthy repairs and having to go back and fix some areas over and over again has been an increase in repair times for all streetlight incidents. As you can imagine, this creates frustration among constituents and honestly among our field crews as well. This slide is an example of copper wire and power theft as we see it in the field. As you can see, folks get pretty creative, sometimes even installing their own electrical socket to our streetlights. Obviously, vandalism like this creates blight throughout the city and creates potentially hazardous situations. As I mentioned, the Bureau has been battling this type of vandalism for some time, and we have taken various measures to try to combat the issue over the years. Early on, we were able to get an amendment to the penal code for recycle center requirements, basically requiring identification from the seller and also to disallow cash transactions. We were able to also get changes to AB 844, increasing the severity of the crime for anyone caught stealing our wires to a felony. Over the past 10 years or so, we've implemented a variety of solutions as needed and as they became available. We've installed lockable pull boxes in areas with high levels of copper wire theft. And this works, but since we have over 200,000 pull boxes, we were following incidents and curtailing repeated hits rather than preventing the actual crime. In more recent years, we have begun to weld base doors and handholds shut. We are looking at ordering pulls without handholds or with handholds raised above hand level or eye level. We've also upped our efforts with community outreach and education regarding our challenges. And finally, we've implemented dedicated copper wire theft crews in our field operations so that we no longer have to pull crews from regular maintenance work for these issues. The more streamlined response has sort of paid off, and we have gotten a better handle on our vandalism incident repair numbers in the recent months. We're going to continue, obviously, to work on preventative measures in the upcoming years, as well as ramp up our community outreach and involvement. To conclude, the operation and maintenance of 223,000 streetlights spanning nearly 500 square miles here in the City of Angels, the second largest city in the United States, is definitely a daunting challenge. But it is a challenge that we welcome and embrace every single day on behalf of all Angelinos. Thank you.
Hi, I'm Kerney Marine, Assistant Director with the Bureau of Street Lighting. Today, as part of the Bureau's Smart City Conference, I will be giving you a brief update of our LED conversion program.
Before I do, I want to tell you a little bit about our Bureau. We were established as a bureau within the Department of Public Works in 1925, so we're closing in on our centennial anniversary. We are responsible for the design, construction, operation, and maintenance of all of the streetlights that illuminate the public right-of-way within the city. That includes roadways, sidewalks, bridges, tunnels, bike paths, and other public right-of-ways. Today, there are approximately 400 employees in our bureau. The city of Los Angeles itself is made up of several communities. As you can see, there are a lot of familiar names here. Often people think these communities are their own cities. In a way, they are. Some of these areas do have unique styles of streetlights that identify them, but they are all part of our beautiful city of Los Angeles. The city of Los Angeles is approximately 470 square miles. There are 6,500 centerline miles of streets and 223,000 streetlights, as depicted by the green shaded areas on the map in the center. They illuminate about 4,500 miles of streets. Our system is the second largest municipally owned street lighting system in the country. I believe we're right behind New York City. And there are over 400 different styles of streetlights in our system. Many are over 100 years old and are irreplaceable. Shown here are some of the many different styles of streetlights that are in our system. These photos were actually taken from our downtown museum, which had been open to the public just before the pandemic hit. I've also included a few more photos of some of the different types of streetlights in our system. This slide shows the first street lighting system in Los Angeles. The center photo is a photo of Main Street. In 1867, the Los Angeles Gas Company installed 43 gas lamps that illuminated Main Street. The far right photo is the first electric streetlight in the system. This was in 1882. It was an electric carbon arc lamp streetlight. 5 of these 150-foot streetlights were installed to illuminate the downtown area. On the left side of the slide is a lamp history, and the years show the street lighting technology that was used at that time. I would suspect that the use of street lighting technology was very similar throughout most of the country. With the exception of LED, Los Angeles was the first major city to immerse itself in LED technology for the use of street lighting. Real quick, a slide about our finances. The operation and maintenance of our street lighting system is funded by annual assessments to benefiting adjacent property owners and is included on their annual property tax. Now, for over the last century, this revenue had increased yearly based on our operational needs. It grew annually until 1996 when Proposition 218 was passed in California. Proposition 218 requires a ballot process to establish a new assessment or to increase any existing assessment for a special benefit, such as street lighting. When this proposition was passed in 1996, it froze the Los Angeles City Lighting District. At that point, it was about $40 million. Today, it's just over $40 million. The power utility in the city of Los Angeles is owned by the city. That is the Los Angeles Department of Water and Power. Our Bureau pays energy fees to the LADWP for the energy that operates our street lighting system. Now in 2008, 2009, we had the perfect storm. Our assessments were frozen for the last 12 years at that time. Our operational costs were rising, energy costs were rising, and LED technology had just emerged as a viable option for street lighting purposes. So, our LED conversion program. As I stated, by 2008, LED technology had evolved to a viable option for us economically due to the state of our bureau at that time. We began with the conversion of Cobra heads, or low-hanging fruit. I like to say that LA led the way, as we were the first major city, I would suspect, in the world to immerse itself into LED technology for street lighting. At that time, we began pilot testing many different types of LED luminaires that were sent to us by different manufacturers. We established a pilot project that installed, I would say, a dozen different LED fixtures in neighborhoods throughout the city. In the field, these units were evaluated for their illumination performance, glare, light trespass, and general appearance. We established a testing lab in our downtown office where these luminaires were tested mechanically and electrically and assessed both to verify manufacturers' claims and to ensure that the equipment met our needs as well as met IES recommendations. To date, we have tested and evaluated over 1,200 different LED lighting units. Throughout this process, we evolved a set of specifications that we utilize today. This slide indicates some of the specifications that are required for new luminaires that we want to test or evaluate for our system. I won't go over all of them, but Some of them are, we require a 3-prong 7-pin twist lock photocell receptacle. The driver must be located in the housing, be field adjustable, and have dimming capability. These specs are for use as we move into smart city technology. Other notable specifications is that the luminaire must produce a 3000 Kelvin temperature and provide a minimum 10-year warranty. These are just a few photos of the different luminaires that were submitted to us over a decade ago as part of our pilot program. There's quite a difference in each one of these luminaires. Now, the decorative lighting conversion is what we focused on over the last, I would say, 5 or 6 years. And both the pendant, post stops, high mast, and wall lighters were a very significant challenge to us. Now, initially, when we started our LED conversion program back over a decade ago, we were approached by many manufacturers that suggested we use their LED units to replace the existing ornamental type fixtures. Now, back then, these units were, and they still are, quite costly, and at the time didn't quite illuminate properly. So our decision was to retrofit these types of fixtures with LED conversion kits. Cobra head conversions were easy. Now, the conversion of decorative fixtures initially was challenging. As I said, we had to develop ways of retrofitting the various different types of ornamental fixtures in our system. The photos here are typical of some of the older equipment that were challenging to convert. There were some retrofit kits on the market at that time, but very few were universal or had a reasonable return on investment. We actually took a fairly aggressive approach, actively seeking out and testing equipment that seemed promising, even if it required considerable engineering work to adapt it to a specific application. So with so many styles of luminaire, kits were custom designed by our engineers and field crews for the different types of luminaires. In general, we typically utilize the tower type of lamps for decorative units that were part of a dual Cobra head system where the coefficient of utilization was poor for that type of application. So the illumination was provided by the adjacent Cobra head. Now, the use of the LED disc mounted on an adjustable shaft directing light down was much more efficient and necessary if the decorative luminaire was the sole source of illumination. Pendant luminaires also benefited best by using a downward facing disc. I've included some before and after shots. This is a photo of the Venice walkway out at Venice Beach before we used LED lighting. As you can see, there's a real carpet effect with LED lighting. This is Major La Brea Avenue before and after. Again, another local street, La Mirada Avenue before and after. And these are some photos of typical underpasses under freeways. Obviously, the left photos are before and the right photos are after. Again, these photos and many more can be seen at our website that I have given you on previous slides, and I will do so in a few moments. Now, this is a slide we've used. We've done many presentations about our LED program over the last decade. This one kind of tells you the benefits of using LED luminaires versus high-intensity discharge luminaires. Obviously, LED luminaires are smaller, easier to transport. You don't need to carry extra components like you do for HID lamps, such as lamps and starter kits and spares. Warehousing benefits because there's no need to store a bunch of spare units. There's smaller boxes if you do. Again, the LED advantages are uniformity ratios. You get that carpet effect. It allows for designs with smaller wire and conduit size for new installations. And obviously, using dimmable drivers is a benefit for smart city applications. This is a summary of the installation of energy efficient fixtures in our system. Again, we have over 223,000 streetlights in our system. The first 5 years, we converted 140,000 streetlights. And from 2012 on, we averaged a good 10,000 every year thereafter. We've converted a total of 202,000 streetlights of our 223,000, which is 91%. Again, for the totality of the program, we've averaged a good 20,000 conversions per year. We still have about 20,000 units remaining, although I think that number may not be accurate as our as-builts are falling a little bit behind. We probably have less than 20,000 left. I've indicated here our Bureau's website, bsl.lacity.org. At that website, you can find what luminaires are approved for use. You can see some of the photos that I've included in this deck. There you can also find out what other type of LED fixtures are approved for use, such as pendants, wall lighters, and actual lamps that we actually use for some of our LED conversions. Our Bureau in this site has been a reference for many entities seeking to implement LED street lighting technology. Summary of our conversion program. Annually, we see an energy savings of about 122 gigawatt hours, which equates to a little over $11 million every year in energy cost savings. We see a reduction of 72,000 metric tons of CO2, reducing our carbon footprint. We've determined that a 3000 K color temperature is optimal for roadway use, and we require a 2600 color temperature for decorative fixtures. The use of LED technology has drastically reduced our maintenance cost, which enables our maintenance crews to collaborate with other city forces on construction projects, which saves the city money. These projects would otherwise have to be contracted out. The use of LED technology reduces our loads on our circuits, which allows for the installation of additional infrastructure on our poles, such as EV chargers and telecommunication antenna and other smart city applications. On this slide, you see two photographs before and after of the 6th Street Bridge, which no longer exists. I've included an artist's rendition of the 6th Street Viaduct, which is now under construction and should be completed within the next few years. These are photos taken from Mount Wilson. First is in 1908, and the second one is 110 years later. You can see there's not too much difference in the dark sky. This photo shows the flaming effects of the high-pressure sodium lamp which dominated the city's landscape prior to our LED conversion program. In the photo below is the same Mount Wilson shot after the completion of our LED conversion program. I want to thank you for giving me the opportunity to update you on our LED conversion program.
Hello everyone, I hope everyone's having a great day. And welcome to the LA Smart City Street Lighting Conference, hosted by the Bureau of Street Lighting. I'm here to talk to you about remote monitoring devices and its role in smart city infrastructure. Now, what comes to mind when you think of smart city? EV charging stations, smart lighting, LED lighting, co-location, network systems, mesh and cell, solar, air quality monitors, CCTV cameras, and much, much more. What you may not know is that remote monitoring devices, or RMDs for short, are essential to smart city. If the streetlights are the backbone of smart city, RMDs are the brain. They may be not as physically noticeable, but they play an essential role in communication of our streetlights and ultimately our smart city devices. As we go through the presentation, I'll explain how we use the nodes, their different functions, and why they're so important. Here's an example of a remote monitoring device installed in the field. Remote monitoring devices provide control and visibility through a centralized dashboard. What I mean by this is that we can turn on a specific set of lights or multiple lights all at once. We can also use filters to see which lights are working, have power outages, or are malfunctioning. This ties into our next point for feedback for light monitoring. For example, if a specific set of lights are out on one side of the street and they are in alignment with the circuit of that area, we can probably conclude that the issue is at the service point. Or even worse, copper theft could have occurred. If it's one individual light, it could be a luminaire issue, power issue, or something deeper. In this way, we can save time and money on maintenance, allocating our field crew's focus and resources on specific locations. Also, we can monitor energy usage to make sure the luminaire is functioning efficiently. This is what the City of Los Angeles streetlight infrastructure looks like on the RMD centralized dashboard that I mentioned earlier. In a city with over 450 square miles of land, maintenance efficiency is key in keeping the street safely lit at night. As we zoom in, each yellow dot represents a streetlight that is currently controlled or has the potential to be controlled by a remote monitoring device. Before RMDs, we relied on residents to inform us of broken streetlights. This could take weeks, months, or even years in some cases. Now we know within 24 hours when a light doesn't work and can have it repaired in a timely manner. This is a close-up of some streets in our management system. Here you will see the different alerts and symbols that let us know whether the system is operating properly or not. The dark yellow circles represent street lights that do not have nodes on them. The bright yellow lights represent street lights with nodes on them and that are functioning properly. The purple circles and triangles with exclamation points in them represent lights or nodes with faults that we can look into. The green dots represent uncommissioned nodes, meaning that the node is there physically on the light, but we have not yet connected it into our system. Here's what it looks like when we click on an individual light and look at its information. As we can see, the light turns on about 8:30, 8:45, and the light turns off around 5:30, 5:45. This is a summer day or summer month. The next slide shows an example dashboard of energy usage for 1 year and 1 month, with the x-axis being the month or day and the y-axis being energy usage in kilowatts per hour. Since the RMDs that we use have an energy meter accuracy of 2%, we are able to confidently know our energy consumption. In comparison, here's an example of a street light that had an issue where it was using too much power. An alert was sent, we had a maintenance crew go out to fix the problem, and now the street light is putting out the correct amount of light for the street it's designed for. Without the instant alert, this particular street light would have been wasting electricity, polluting light, and would have ultimately burned out sooner than expected. One topic of debate in RMD technology is how they communicate. The two options that we had to choose between are mesh and cellular. In order for the mesh network to work, All the lights need to be connected and within range of each other so that they can communicate with a gateway to get information back to us. This works if all your lights are close together, but what if you install a single street light way off by itself? Unfortunately, the latter happens more often than you think here in LA. While both systems have their advantages and disadvantages, ultimately, we decided to go with cellular. While the upfront cost is more, cellular gives us the flexibility to install anywhere in the city without adding extra equipment to service and maintain. For us, the benefit of having the RMD work independently far outweighed the disadvantages of using the cellular network. Another function of remote monitoring devices is light adaptation. What I mean by that is that we can set certain lighting outputs for certain situations. For example, we can set schedules for big events. Two recent projects we implemented was the LA Live Staples Center and Hollywood Bowl. For LA Live Staples Center, we made sure to increase lighting by 30% from 9 p.m. to 12 a.m. so that fans can get to their cars safely after Lakers, Clippers, or Kings games. And it's the same with LA Live or Microsoft Theater event attendees. For the Hollywood Bowl project, which we just completed last month, we can also provide better lighting for concert attendees after concerts so they can safely get to their cars. Especially with the limited parking at the Hollywood Bowl, many concert goers park along Hollywood Boulevard up to Highland Boulevard. In this project, we use a 50% increase. This increased lighting schedule provides a win-win for the public in relation to their safety, all the while saving energy and tax dollars. The pictures you see are of increased lighting at our adaptation projects, as well as a map of the different lighting zones we created for these projects. Here's an example of a light within our adaptation zone at LA Live. Unlike the previous example that showed the light operating at a single current the entire night, this one increases by about 30% during times of increased foot traffic when sporting events or concerts are over and people are walking back to their vehicles. With everything that we've presented here today about the benefits of RMDs, why are we still using technology that was made popular in the 60s? I'm sure some of us remember this, and this. And don't get me wrong, I'm sure they were great 60 years ago. But I'm sure today you'd much rather make phone calls on this or watch your favorite program on one of these. Bottom line is PE cells are one-dimensional, while remote monitoring devices have a multitude of functions and can pay for themselves if used properly. If street lights changing from HID lamps to LED was the first step for our industry to move into the 21st century, the use of remote monitoring devices is the next step. Alright, that pretty much wraps it up for our presentation. Last but not least, here's a list of references that we used for pictures and information. Down below is our email contact as well, for anyone that has questions or comments for after the slideshow. I hope everyone found the presentation useful, and I hope you enjoy the rest of the conference.